This is our phased patch antenna array in 5 minutes. For our senior design capstone project, our group is going to design, create, and demonstrate a satellite phased array ground station. The future of communications belongs to the phased array antenna. The recent boom in satellite development has resulted in a dramatic rise in the number of satellites launched per year. Satellite communication requires a ground station to receive and transmit data. Traditional ground stations maintain communication with one satellite at a time, while phased array antennas hold the advantage of communication with multiple satellites simultaneously. Our goal is to receive and track at least 2 satellites simultaneously using an Inmarsat or Iridium downlink. To understand the basic concept behind the phased array antenna, we will follow the path of the signal from the transmitter aboard the satellite. The signal from the transmit antenna will travel through several mediums to our phased array ground station receiver. Due to the diversity in this space, each antenna in our antenna array receives the signal at a different phase. With the use of phase shifters, we can alter the phase of each signal to individually, constructively, or destructively interfere with the total signal to achieve our desired results. This concept, known as beamforming, is achieved through the use of electronic steering. Design-wise, following the receiving of the signal, each individual antenna will pass its signal through an LNA, or low noise amplifier. Then, each individual signal will pass through a phase shifter to align the signals, an attenuator to balance them, a bandpass filter to isolate the signal, and then an SDR to digitize the signal stream. Following that, the paths shall be sent to the PC to be processed. The signals will be modulated so that we can interpret them in regards to our desired direction. Our goal is to be able to dynamically switch between satellites in our SDR interface. One of the design challenges we faced was whether to use an analog or digital device to phase shift our signals. We concluded that digital phase shifting will exceed in the speed required for tracking multiple satellites, offers higher fidelity, is easier to control, and is less prone to introducing noise to our signals. By introducing an external synchronous clock to the SDRs, we will be able to accurately phase shift the individual signals. The power of the phased patch antenna array is its ability to produce a sharp bore sight with high gain. Each antenna element can be phase shifted, which allows the array to be electronically steered towards our desired satellite. Our group will begin with a 2x2 antenna array and may increase our dimensions after initial testing. We will be operating such that we will be able to receive L-band downlink with a center frequency of 1550 MHz. The following diagrams were simulated in MATLAB from our desired frequency range and gain requirements. These simulations allow us to see our antenna's capability in receiving left-handed and right-handed circularly polarized signals. Our team is working on a strict timeline. We have our basic design requirements already determined. Design research will be completed by December 17th, prototype build and testing by January 30th, further prototype testing to be completed by February 13th. We will move into our final stages in the last months of February, April, and May, where we will delve into our final design implementation and system specifications testing, with our final Capstone showcase in May. Our group has been working in 2-week design cycles and using agile methodology in our frequent meetings to isolate ideas and improve our designs. We estimate our funding requirements to be at no more than $1,500. Our team is as follows: Cameron Green, that's me, Antenna and Signal Path Design; Marissa Navarro, Signal Processing; Daniel Toth, Antenna and Signal Path Design; Stephen Dahl, Systems Engineering Management; and Alexander Sid, Systems Engineering. Thank you for watching our phased patch antenna array in 5 minutes.